In the previous video in the series, we put together a rudimentary lexical decision task experiment in PsychoPy, and we did it all in the PsychoPy code review. So we wrote the Python code for this experiment, and our motivation is just having a baseline understanding of how the code of experiments work, because even if you're working in the PsychoPy builder view and you're using the visual interface to construct your experiments, sometimes you will find yourself needing to pop the hood and look at the code underneath or include custom code components in your experiments. So it's a good foundational skill I recommend for anybody working with PsychoPy. Now in this video, I want to take things a step further with our experiment and add some more advanced features to it. And so in preparation of that, let's start by just looking at our experiment as it currently stands. So here's our experiment window. It starts off with a set of instructions. The user is told to press the spacebar to begin, and then they're going to be shown a series of words or pseudo words, and they are to press the left arrow key if it's not a word, and press the right arrow key if it is a word. So bar is a word, I'll press the right arrow key. Ool is not a word, I'll press the left arrow key, and I'll continue with this pattern until eventually we get to the end of the experiment. So that's where things currently stand. And if we go over to the notes that accompany this video, I have a list of features we want to add to this. We want to make it so that our conditions, our words and pseudo words that we're displaying to the participant, I want to load them from an external CSV file. Right now, they're just hard-coded in our experiment itself. By moving it to an external CSV file, that'll give us a little bit more flexibility. We could potentially use different source files for our conditions. I also want to include a pause between displaying each condition, and I want to record the reaction time from the participant for each condition. And then finally, I want to write the results to an external CSV file. Right now, the results are just printed to the console within the PsychoPy window, which was useful for development and testing. But obviously, when we're running experiments, we want to collect data, be able to analyze that data. And so being able to write results to an external file is key to that. And in terms of the participant experience, I do also want to add an exit screen, because right now the experiment, when it gets to the end, it just abruptly ends. So I want to have a nice thank you message at the end and then give the participant the option to actually close the window. So with those goals in mind, let's jump right in. And the first thing I want to do is think a little bit about the organization of this experiment. Pulling up my Finder window, in the first version, I just created a Python file and I just threw it on my desktop. So it was a single file for this experiment. But now that we're going to be dealing with multiple files, we're going to have an external conditions file. We're also going to be writing results files. I think it makes sense to organize this all under a subdirectory. So I created a subdirectory called LDT, short for lexical decision task. And if we look at the contents of this, I have 3 files. I have the Python file for the experiment itself. I'm just calling it ldt-v2.py. And then I've got 2 condition files. And that's actually a good place to start, is these condition files. So let's start with conditions.csv. I'm just going to open this up in a basic text editor. And what we have here is a CSV file, so comma separated value file. At the top is a header indicating what data we have in this file. So the data we have is a series of words, and then we have this value is word, which is either going to be true or false, or we're representing that as ones and zeros. So cat is a word, so we represent that as 1 for is word. Bar is a word, that is also 1, T is 1, and then here we get to our pseudo words where we could see the is word value for them is 0. And if you're joining us from the previous video, this should look familiar because it just mirrors the same data structure we had set up. Just switching back to PsychoPy, I'm looking at the first version of our file where we had created our conditions in a Python list. It's that same data, we just have it encoded in this CSV format. And if you're following along and want to set up your own conditions file, if you go over to the notes that accompany this video, I do have this data here, so you can just copy and paste it and create a conditions.csv file without having to type everything out. The other thing you can grab if you're following along is the code for this experiment as well. I've got the version 2 code, so you can copy that. I went ahead and set this up before recording this video just to expedite things. So again, coming back to my LDT folder, you can see I've got that version2.py file. That's what we're going to be looking at and walking through. So let me go back to PsychoPy and actually open that up. So on my desktop, I'm going to go to my LDT folder and open up that version2.py file. And one of the first things you'll notice that's different from our first version of this experiment is we have the addition of a new module we're importing. We're importing Python's CSV module. This is what is going to give us the ability to open up and parse through our conditions CSV file. Where you can see that happening, if we skip down a little bit, starting on line 10, the syntax here is with open. And then the first parameter we're going to pass to this open method is the file path of our conditions file. That's what we're opening up. Now in this example, the conditions file exists in the same directory as this Python file we're working in. So I don't have to include any special path instructions on where to find this file. I just need the name of the file. But let's say I had organized things a little bit. Let's say I had a subdirectory in here called data, and that's where I put my conditions file. If that were the case, I would just need to make sure that I'm including that path when referencing that conditions file, so it would look like that. All right, but like I said, I did keep things simple, and I'll just revert those changes I just made. These two files exist in the same directory, making my paths very simple. The second parameter passed to the open method is this new line parameter, and we're setting it to be an empty string, which is going to be what you're going to want to do for most CSV files. It's basically just indicating how the CSV file is going to be parsed, with the idea that each row of data is separated by a new line within that file. There's some other values you could set this to, and it gets a little technical. If you look at the documentation for working with CSV files and the open method, you can learn more about that. I don't want to get too lost in the weeds, so I'm just going to gloss over this right now and just say for most CSV files, just set new line to be this empty string, and it should work as expected. So that all sets us up to open the file, and then the actual reading of the CSV data happens down on this line, line 13. We create a variable called conditions, and we're setting it to be the results of we're invoking this reader method from within that CSV module that we imported, and we're telling it to read in the CSV file, which we opened up here on line 10. Now, what this returns is called a reader object. It's a special object type within the CSV class, but what we want is just a basic Python list with this data. So to convert that to a Python list, we just wrap it in Python's list method. Now, to help visualize what this line is actually doing, I'm going to temporarily throw a print statement in here and just have it print out what conditions is at this point after it's opened the file, it's read it in, and then converted it to a list. All right, so let's run our experiment. And just moving our experiment aside, I want to focus in on the output. And here is our conditions data. So we can see we've got a Python list. And then within there, each row in that CSV file is represented by another list, where the first element in the list is the word or the pseudo word, followed by 1 or 0. And this replicates, if we go back to the first version of this experiment, it basically replicates what we hard-coded when we created that Python list, but we're just pulling it in from the CSV file. Now, the other thing to observe as we're looking at our conditions is the first element in the conditions is not actually a condition itself, it's just the header of our CSV data, that word and is word marker. And when we're running our trial and we're running through these conditions, we don't actually need that to be one of our conditions. So after we load the conditions, I invoke a pop method on it, and I indicate I want to pop the first item off the list. So that's going to remove that first element from the list, and then we should just have our data. And let's see that. So let me take a moment to close the experiment that's currently running. And I'm going to just move down the conditions, or the printing of the conditions, to after this pop statement. And we should see that it removes this first word is word header. All right, perfect. So now we end up with just our data. And then just like we did in version 1, we then want to shuffle our data. And then finally, I've set a variable called conditions count that uses Python's length method, or len for short, to see how many conditions we have. And I'm going to use this later because one of the features I want to add is a pause in between each word. And I want to do that for all of our conditions, except for at the very last condition, we don't want to pause after it. So by knowing how many conditions we have, we can basically find out if we're at the last condition and omit that pause at that point. So this is a tool we're going to use later in the code. All right, so just to summarize, what we just did is we opened our CSV file, we parsed it into a list, we did a little bit of manipulation on the list in that we got rid of the first element, we shuffled it, we basically got it ready for our experiment. So with our conditions set up, let's proceed through the rest of the code. And it looks like I've got the experiment still running, so let me just take a moment to quit that. Okay, great. So here on line 26, just like we talked about in the previous video, this line is just setting up our experiment window. We're creating a 800 by 700 window with a black background. Following that, we define a welcome string that has our welcome message for the participant. And then where that's used on line 43, we create a text stem This is a PsychoPy component that we're creating here. It's basically going to be a text element on the screen. We specify some parameters. We indicate which PsychoPy window we want to attach this to, and we're just attaching it to the window we created above. We want the font color of this text to be white. We set the text itself to be our welcome variable defined above, and then we indicate the size of the font. All right, now once we have that initialized, to make it actually display in the screen, we invoke the draw method on it, and then we have to flip our window. And we talked about this in the previous video. Remember that with PsychoPy, you can imagine you have a little whiteboard, and you as the experimenter can write the details of the experiment on the whiteboard, but then for the participant to see it, you have to flip that whiteboard. That's what we're doing here. We're flipping that window to actually display it to the participant. So that displays our instructions, and then we wait for the space key to proceed. And then upon proceeding, that leads us to our for loop that is going to walk us through our trials. So the for loop in this case, I've expanded a little bit. If we return to the version 1 of this experiment, it was very simple. We simply just said for condition in conditions. But now I say for index comma condition in enumerate conditions. Now, the reason I did this is because as we iterate through our conditions, I wanted to know not just the condition itself, but the index position of that condition. All right, so when we have a list of items in Python, each item in that list has an index position. The first item in the list is at the 0th position. The next item in the list is at the first position, and then the second position, so on and so forth. Now, I want to know that index because returning back above to our conditions, remember I talked about I found out how many conditions we had because I want to know when we're at the last condition. Well, in order to do that, not only do I need to know how many conditions we have, I need to know which condition we're at as we're iterating through. And giving us access to this index position allows me to do that. So that's the motivation behind this expanded for loop as I've written it here. And then the technical details of how we're getting the index, we're taking advantage of Python's enumerate method, which allows us to feed it a list and have it give us the elements in that list as well as the index position, which we're capturing in this case by these two variables, index and condition. All right, so long story short, index is going to hold a numerical value representing which condition we're at, and then condition is going to hold the actual condition itself, which is going to be those sublists of things like cat1, bar1, t1, depending where we are in the list. All right, now in the for loop, the first thing we do is we figure out what the characters are, and we get that from the 0th element in the condition itself. Right, so again, referencing our list. Let's say we're in the first element in the list. If we say condition at 0, that's going to be cat. That's what our characters are that we want to display. And then condition at 1 is going to be a Boolean value as to whether it's a word or not. So that'll be either 0 or 1. All right, now using the character information, we can initialize another text stim that we're going to display in our PsychoPy window. So once again, we tell it which experiment window we want to display this in. We indicate the color, we indicate what text we want to display, and this is just going to be our characters variable, and then we indicate the size. Then just like we did to display our instructions, we're going to draw the text stim that we just created, and then we're going to flip that window. Now following that, we have some new code for this version 2. We create a variable called start time, and we're going to invoke the core PsychoPy module, which is one of the modules that we're importing. Within there is a method called getTime. So we're going to record the time right after they are shown that text stimulus. And then just like we did in version 1, we wait for the response of either pressing the right or the left arrow key. And then immediately following that, we're going to look at the time again. We're going to take the current time and subtract the start time that we recorded before we started waiting for the response. And the end result is we can calculate their reaction time. Right. Then following that, we check their response accuracy, and there's nothing new in this code that differs from version 1. We're just looking at the current word in our condition. We're looking at their response, whether it was the right or left key. If it was a word and they pressed the right key, then we mark correct as true. If it's not a word and they press the left arrow key, we also mark their response as true. And then if it's neither of those conditions, we can assume that their response was incorrect, so we mark that as false. Right. Then we get down to building our results string. And again, this is very similar to what we saw in version 1. we take this results variable and we're going to append onto it the characters that the participant was just shown, whether or not it was a word or not, whether or not they got it correct, as indicated up here. And we're also including their reaction time as part of our results data. Now, in version 1 of this code, the results variable, when we first initialized it, we initialized it as an empty string. And just to show that again, I'm going to jump back to version 1 and scroll to the top. We started with just an empty string and we added onto it. Here in version 2, because we're going to be ultimately writing this to a CSV file, I did want to have a header on this data. So you'll notice at the top of this version, when I initialize my results, I'm giving it a header of what data is going to be in this file. Right, so we have characters, is word, correct, and reaction time. Those are the 4 data points within this file. So that's how I start out my results string that's going to be written to our CSV file. Now, if any of that's fuzzy, I think it'll become clearer when we actually see the results. So hang with me on that. I do want to get through the rest of the code before we actually see the results that are written. All right, so scrolling back down, I'm just going to the end of the for loop. And the last thing we're going to potentially do with each of our trials is I do want to have like a pause moment between each of the words that we're displaying. Now, I only want to do this if we're not at the last word. So I did wrap this in an if statement where we're looking at the current index. And remember, we had set up our for loop, so we know the index as we're going through each condition. We're saying if the index does not equal the total amount of conditions we have, which is represented by our conditions count variable, -1. And we do -1 because our index always starts at 0. But if this is not true, in other words, if we're not at the last condition, then we're going to display like a pause character in between each word. So to set that up, I just create another PsychoPy text stim. But the text for this is just going to be a simple plus sign. And this is very common. You'll see this in experiments in between displaying images or other text. You just have like some sort of generic character that you display. And of course, at this point, we know to display this text stimulus that we just created, we have to invoke the draw method on it and then flip our window. And I'm calling this word, but I don't think that's appropriate here because this is not actually a word we're displaying. I'm going to call it pause instead. I think that makes it a little bit clearer. So I'm going to modify that. And I'll modify that on the notes that accompany this video. So you might already be seeing that if you're following along on the code that you copied from the website. All right, now I do also include a core.wait here. So this is referencing the PsychoPy core module, which is something that we are importing above. And we're saying wait for 1 second. So this is introducing an actual pause in our experiment before it would continue to the top of the loop and begin this process over again. Right, assuming it wasn't at the last condition, at which point we know that this code wouldn't at all be executed. All right, so that's the setup for our pause. After the for loop, after we've gone through all our conditions, we then want to write our results to a CSV text file. So here we're going to say with open, we're going to come up with a name of our results file. I'm just calling it results.csv. The second parameter we're passing to open is what mode we're going to be opening this file as. And I'm using W because we want to be able to write to this file. We're not just reading the file. In that case, we would just have an R character, but here we want to be able to write to it. And then within this with open structure, we're simply going to take that results variable that we had built upon in our for loop, and that's where we're going to write to this file. The end result is just going to take whatever data we had in that variable, put it in a text file called results.csv. Now I'm also printing the results to the output. This isn't really necessary anymore because we could just look at the text file that's created, but sometimes in development, when you're working on an experiment, it can be convenient just to have the results also displayed in the output, so it doesn't hurt to have that there as well. Now to wrap things up, the very last thing we do is we set up a exit screen. So we create another text stimulus with an exit message. I just say, thank you for participating, press the spacebar to exit, and then we display that on the page, and then we just wait for the spacebar, at which point the code would proceed, and you can see the last 2 lines of the code are just going to close the experiment. All right, so let's see all this together. Now that we've seen all the code, let's see what version 2 of this experiment looks like. I'm going to go ahead and run this. So far, it starts off just like version 1. We see our welcome instructions. I'm going to press the spacebar to begin. We see our first set of characters, Jewel, which is not a word, so I'm going to press the left arrow key. And there you saw just for a second our pause character, that plus sign. If you missed it, let me answer this again. So I'm going to press the left arrow key again and wait for that pause character. All right, so hopefully you're noticing that as we're going through, and I'm just going to keep proceeding till we get to the end of this experiment. All right, so that was the last condition, and then here is our exit screen we had set up. Nice thank you message, and then the participant can just press space to exit the experiment. And as discussed, we should see our results in two different places. The first should be in the output console within PsychoPy. So let's scroll up and see if we can find that. All right, there we go. So there's our CSV data of results. So we've got our header we talked about. Remember, this is what we set up at the top of the file. And then here is our data. So we have the characters that were displayed, true, false as to whether it was a word, and then true, false as to whether the participant got it correct. And then here is the reaction time. I want to pause the video for a moment here. As I was editing it, I realized that the results we're seeing are actually inaccurate. For this third value that's marking whether or not the participant got the response correct or not, it is showing 0 or false across the board. So I took a moment to look into it, and I'm just going to transition over now to the current code, and I want to explain what the problem was. It happens with the fact that when we started getting our conditions from this external CSV file and we imported that data, it's all coming in as string values. And this causes a problem later down in our code when we're checking the response accuracy. We're referencing this is word, which if we rewind, it's coming from our conditions, which came from that CSV file. And rather than getting is word as an integer of 1 or 0, it's actually reading it in as a string 1 or a string 0. And because of that, for our comparisons down here, we never actually get a true response to any of these first two Boolean expressions, because when we say is word, is it equivalent to the integer 1? Well, that's never going to be the case if we're always dealing with a string 1. Same thing for when we're comparing it against a 0. So the fix here is just when we're pulling the word from our conditions, I'm just going to wrap it in Python's int method, and that's just going to convert our 1 and 0 in their string format back to an integer value, and that should make our response accuracy checking work more as expected. Now, I will definitely update the website with the correct code for this, but I did want to pause the video just to point that out, especially if you were looking at the results and wondering why they're inaccurate. But with that fix aside, let's get back into the rest of the flow of the video. All right, now this output data should also exist in that results.csv file. So let me bring up my Finder window. And perfect, there is results.csv. Let's open that up. And that looks good. There is our CSV data in its own file, ready to be imported to whatever data analysis program we used to use. Now, one flaw, though, I'm thinking about now as I'm looking at this is every time we run this experiment, it's going to save the results in this same results.csv file. So it's effectively going to overwrite our results every time we run this experiment. What we should be doing is creating unique file names for each of the runs of this experiment. And a simple way I can think to do that is, let's go find the code where we're creating this results file. Rather than just statically naming the file results.csv, to make it unique, let's interject the current time code of when the experiment's running. To do this, we do have to import another module. Python has a time module, so we're going to say import time. And then going back to this file name, we're just going to interject into this. I'll use Python's concatenation operators. We're going to reference from that time module. There's actually a time method. So we're just going to invoke that. And then we're going to make sure that's a string. So I'm just going to wrap it in Python's string method. And then let me just fix my spacing here. And let's go ahead and add a dash after results. All right, so this should be results dash, whatever the current time code is, followed by the file extension. Let's make sure that's working as expected. So let me run the experiment again. And I'll just quickly go through this. And then let's go to our file or our directory again, and perfect. There is a unique results file with that given time code. And so we would be able to collect them for each participant in each run through the experiment. Now, another thing we could have done, just to put this on your radar, is there are ways in PsychoPy to create dialog boxes. So let's say your participants had unique participant IDs. You could collect that via a dialog box where they can type in their ID, and then you could use that ID as part of the file name as well. That would be another way to distinguish these files. That's a topic for perhaps another video on how we could expand this experiment. But if it's something you want to research independently, you want to look into PsychoPy's GUI module, you can look in the API docs for that. Also include a link in the description on how to get custom input from the user. But to wrap things up for this video, there's one last tip I want to leave you with, and it's this conditions-dev CSV file that I have in this directory. If we open this up, you can see it's just a simplified version of our main conditions file where we have just 2 conditions. And this is something I recommend when you're building an experiment and you have a long conditions file. In my case, my conditions file it's not that long. I only have 6 words, but let's imagine I had 100 words. And every time I wanted to run and test my experiment, I don't want to have to go through all 100 words, especially now that we added a 1-second pause in between them. Creating a development versions of your conditions file that has just 1 or 2 conditions can really just expedite the development process because you can have basically like a shortcut version of your experiment to run through. All right, and the way we would use this, just while we're in development, we'd come up here and update the path to our conditions file to point to that dev file. And now we could run our experiment with that abbreviated list. All right, just to show this would be much quicker now. We just have to go through 2 conditions. We're at the end of our experiment, and we could go back to tweaking the code as needed. All right, so just a little tip there. I recommend that, especially, like I said, if you're working with a lot of conditions. So hopefully this was helpful to see some more advanced things we could do with PsychoPy code. And I hope you'll stick around. In the next video, we're going to switch gears. We're going to look at the PsychoPy builder. We're actually going to build this exact same experiment. We're going to see how we can do it using the PsychoPy builder tools.